All right, chapter 10, chemical reactions. All right, so your chemical formulas. So again, your formula, shorthand way of describing those elements that make up the or ions that make up a compound. So there's three kinds of formulas. So you got empirical, molecular, structural. So those are the three. So your empirical formula, this identifies the elements present in the compound and describes the whole number form. So the simplest whole number form ratio of those atoms with the subscripts. All right, molecular, this is the chemical formula. So this identifies the actual numbers of the atoms in a molecule. And then the third one is structural. So this is, it shows the arrangement of the actual formula, right? So it's kind of like drawn out. All right, formula weight, that's the formula weight of a compound. This is the sum of the atomic weights of all the atoms in a chemical formula. So for example, here I have H2O, which is water. Water stands for H2O. So you have two hydrogen atoms. So the two goes with the hydrogen, and then you have one oxygen atom. So two hydrogen atoms are multiplied times one because hydrogen is number one on the periodic table. And then you have one oxygen atom, and the atom for oxygen is 16. So it's just 1 times 16. So you add those two from the hydrogen and the 16 from the one oxygen atom. 2 plus 16 is 18. So that would have been your formula weight for water. All right, so your chemical equation. So it's a way to describe a chemical reaction. All right, so if you're ever asked to describe what a chemical equation looks like, so on your left-hand side, this would be the reactants. All right, so these are all the ingredients that are reacting together. They're added together. And then on the right-hand side, you have the products. So this is going to be the results of the reactants reacting together. All right, this arrow is almost the same as being an equal sign in a math problem. Okay, so this arrow means yield. All right, equivalent to the equal sign, which means equal to. So reactants are equal to these products, or the reactants yield these products. All right. So for example, down here we have carbon, which is denoted by the capital letter C. And then we have oxygen, which is denoted by the capital letter O. And combined together, that makes carbon dioxide, right? C2O, right? Di means two, right? So we talked about diatomic molecules. Di means two, tri means three, mono means one. So if this was carbon monoxide, it would just be CO. Since it's carbon dioxide, it's going to be CO2. If it was carbon trioxide, it would be CO3. All right. The law of conservation of mass. Okay, so the law of conservation of mass states that matter is neither created nor destroyed in a chemical reaction. So it just changes forms, right? The mass can change forms. All right, so from the viewpoint of an equation, the law of conservation of mass, it looks like the mass of the reactants, so your individual ingredients, on your left-hand side will be equal to the mass of the products on the right-hand side. So this is your initial ingredients. After they react, then you'll have your outcome of your products. Okay, so for example, let's say we burn a log of wood. All right, initially that log of wood, when we picked it up, it was heavy. But after we burn it, we have pieces of it turning into a gaseous stage because it's on fire. So you have smoke being released into the atmosphere. And also you have some of the burned parts that turn into ash and it just sits there in the fire. Okay. So if you added up the gaseous form of the wood as well as the solid mass that was left after it was burned, it turned into kind of like a powdery dust. All right. That's the law of conservation of mass. So the mass of the wood didn't disappear, it just changed forms because it was on fire. All right. So it's not going to look the same as it did before it was set on fire. Okay. So it's going to turn into different forms of mass. All right. Gas as a vapor, and then solid as, the ashes that's left from the majority of it being burned off. All right. All right, so there's different types of chemical reactions. We have oxidation reduction reaction, combination reaction, decomposition reaction, and replacement reaction. We have the oxidation reduction reaction, also called redox reaction. So this is when you have, it's defined as the reaction in which you have electrons that are transferred from one atom to another, and the reaction has two parts. So the oxidation part is, there's a loss of electrons by the atom. The reduction part is there is a gain of electrons by the atom. So oxidation is one part, reduction is another part. The combination reaction, this is a synthesis reaction. So you have two or more substances that combine to form a single compound. The decomposition reaction, it's the opposite of the combination reaction, right? So the compound is broken down into one of three things. It can be broken down into the elements that made up the compound, or simpler compounds, or elements and simpler compounds. It can be a bit of both. Okay, so to decompose just means to break down. And then you have the replacement reaction. So that's when you have an atom or polyatomic ion and it's replaced in a compound by a different atom or polyatomic ion. And then you have your ion exchange reaction. So this is the reaction that takes place when the ions of one compound interacts with the ions of another. All right. And it can either form a solid, a gas, or a liquid from that reaction. All right, we have agents as well. So these are substances that take electrons from other substances. All right, so we call that oxidizing agents. All right, so oxygen is the most common oxidizing agent. All right, another example is chlorine. Chlorine is also an oxidizing agent. So again, these are substances that take electrons from other substances. And then you have a reducing agent. All right, so this is where you have a reducing agent. It supplies electrons to the substance by substance being reduced. So your hydrogen and your carbon, these are your commonly used reducing agents. All right, so reducing agent supplies the electrons to the substance that's being reduced. All right. And then we have our units of measurement. Okay, so Avogadro's number is 6.02 times 10 to the 23rd power, and it's named after Avogadro. And he reasoned that equal volumes of gases contain equal numbers of molecules. All right. The next unit of measurement is the mole. Okay, so this is an amount of a substance that contains Avogadro's number of atoms, ions, or etc. And then we have gram atomic weight. So this is the mass in grams of 1 mole of an element that is numerically equal to its atomic weight. We have the gram formula weight. All right, this is the mass in grams of 1 mole of the compound. All right, that's numerically equal to its formula weight. And then we have the gram molecular weight. All right, so this is the gram formula weight of a molecular compound. All right, so that's the gist of chapter 10.